Hi, this is Pete from Maths with Pete, giving you another hardest question. This is from 2017, paper 1 higher from Edexcel, and this one involves a hexagon, ABCDEF, consisting of two congruent parallelograms where AB equals BC equals X. So I can annotate those right now for you. That's X. If I just write that in black, that'd be lovely. There you go. So that would be X. That's X as well. We are told also that P is the point on AF. So AF is down that left-hand side, and Q is the point on CD, such that BP equals BQ equals 10. So they're both 10. So I could draw a little line from B to P, highlight that as 10, and a line from B to Q, highlight that also as 10. And we're told that given that angle ABC is 30 degrees, so ABC, let's put that in a different color so we can see clearly that is 30 degrees. Now, we are asked to prove that the cosine of PBQ, in other words, this angle in here, the cosine of this angle is equal to this expression here, 1 minus 2 minus root 3 over 200 lots of x squared. Now, if you think about this, we have got to find the cosine of an angle. Now, we're working with triangles. I'll show you how that looks. If we isolate triangle ABC, like so, so we've got A, B, C. We know that the lengths here are both x, so we're looking at an isosceles triangle, obviously. And if we also look at the triangle, draw a little bit bigger because it's a little bit higher, a little bit taller. This is triangle PBQ. Now these two sides are given as 10. And we want to work out the cosine of this angle. I'm going to call it theta just for the diagram purposes here. Now, what we need, think about the cosine rule and what it tells us and what it involves. In terms of variables, the cosine rule involves, you think about it, it's generally given as the square of one of the sides is equal to b squared plus c squared minus 2bc cos A. So, in terms of what's involved, we have all three side lengths and one angle. Now, what we're asked for is the cosine of one angle of this second diagram. Let's label these diagrams. Diagram 1, diagram 2. Now, we need to find the cosine of this angle here, right? Cosine of this angle here. So if we need to do that, then we must know all three sides of this triangle. Well, we know this side here is PB, we know this side here is BQ, and they're both 10, so we know those. What we don't know is PQ. Turn your attention to diagram 1 then, because you should realize that AC is equal to PQ. In other words, this side length is equal to this side length. So if we can work out an expression for AC, we can then use it for PQ because it's the same side length. Okay. Now, given that ABC is 30 degrees, now this angle here is 30 degrees. Now, if we want to then say, for instance, let's call this, I know it's slightly against the lettering, but let's call that side length little a. Well, little a squared is b squared plus c squared minus 2bc cos A. Well, little a squared is therefore x squared plus x squared minus 2 lots of x times x, which is again x squared, times the cosine of A, which is the cosine of 30. Well, the cos of 30 is root 3 over 2. It's one of those exact values you should be committing to memory. Okay, so the cosine of 30 I'm going to now put in as root 3 over 2. Take it a step back and looking at that. So we've just found an expression which we're now going to simplify. Excuse me. Well, 2 divided by 2 is going to cancel. So therefore, simplify this further, collecting like terms, we've got 2x squared minus x squared lots of root 3. So this is a squared, okay? Not a, but a squared. Well, it doesn't matter because we're going to use that a, in fact a squared, and use it for PQ over in diagram 2. But first, we need to rearrange the cosine rule formula to make cos A, or cos theta in fact, the subject. So what we're going to do next is we're going to go, we're going to add 2bc cos A to both sides, so we end up with a squared plus 2bc cos A equals b squared plus c squared. In fact, what I'll do, I'd rather use cos theta so we're keeping track of what's going on. A squared plus 2bc cos theta equals b squared plus c squared. We want to isolate cos theta, so the next thing we're going to do is subtract a squared from both sides, so we get 2bc cos theta equals b squared plus c squared minus a squared. Now we divide both sides by 2bc, so cos theta equals b squared plus c squared minus a squared all over 2bc. So we can now substitute the lengths that we know. Well, on this diagram here we have b and c are both 10, so cos theta is 10 squared plus 10 squared minus a squared. Well, a squared is going to come from our workings from diagram 1. So minus, I'm going to put it in brackets because it is 2x squared minus x squared root 3. In brackets because we're subtracting both the 2x squared and negative x squared root 3, which is obviously going to change its sign, so be very, very careful there. Over 2 times b times c. Well, b equals 10 and c equals 10. So 2 times 10 times 10 is 200. Simplify this. 10 squared and 10 squared is 200. Now I'm going to factorize x squared from these two terms because we've got an x squared on its own here. So take out the x squared, factorizing, leaving you with 2 minus root 3. All over 200. Not quite as it looks here. So separate these two, this single fraction into two fractions. 200 over 200 is obviously 1. And then you've got the second term here on the numerator divided by 200. So that's going to look like x squared lots of 2 minus root 3 over 200, which is the form requested in the question. That was a 5 marker, quite tricky. So I'd advise you when you're looking at a diagram like this, when you're looking at something that on the face of it looks, you're looking for a way in, just think about maybe sort of sectioning off different triangles, looking at a few things, looking certainly at the answer where you're looking at what we're trying to prove here. We're trying to get the cosine of an angle, so that might be a clue to use, the cosine rule, and then you're down to remembering exact trig values and a bit of algebraic manipulation, but obviously it can be done. Right, that's all for me on this question. Look forward to some more coming up from me in due course. This is the hardest question series from Maths with Pete. Drop me an email if you need any support on anything I've gone through today. It's pete@mathswithpete.co.uk. And I'll see you soon. Thank you very much.